Hi again, Sherwood. The second request I got was around problem 19 from the homework set on page 66. So once again, we find ourselves in lesson 2.1 on limits. This time, we're expected to find the limit of this expression as x gets really close to 1. This problem set asks you to determine the limit graphically and then confirm your answer algebraically. So I guess we'll go ahead and start with the Desmos graphing calculator, typing in x minus 1 over x squared minus 1 and seeing what we can see. Here goes. X minus 1 over x squared minus 1 minus 1. Okay, so there's our function, and we're supposed to analyze the behavior around x equals 1. So I guess we can kind of zoom in and see what's going on. Here we go, real up close and personal with this graph. I'm trying to get the inputs to where they're close to 1, and we'll watch the outputs. Okay, and it looks as though they're getting real close to a half. It actually is undefined at 1, which we can explore, but when you're close to 1, the answers are very close to a half. Okay, so let's see if we can try to understand that. The first thing, why was it undefined? Well, if we just plug in 1 into the denominator, we get 1 squared minus 1, which is 1 minus 1, which is 0. And expressions that have a denominator of 0 just don't make sense. So that's why the function's undefined, and that's why we can't use substitution to find this limit. So that leaves us relying on some other tools, and we're given the hint to use algebra here. So as you look at this thing, it might occur to you that you can do nothing at all with the numerator, so that's great. The denominator, however, might strike you as an expression that can be factored, and if you were thinking that, you were right. So here goes. X squared minus 1 is the product of x minus 1 and x plus 1. And so if I want the limit of this expression, that's just really the same thing as finding the limit of this expression. And maybe I can make use of that. In fact, I'm sure that I can. This expression right here is getting divided by itself, and we know that something divided by itself gives 1. So we can simplify. And so in the numerator, we're now left with 1. In the denominator, we're left with 1 times the expression x plus 1, which is x plus 1. And we're here. Okay, earlier when we tried substitution, we ran into a problem. The algebra actually resolves that problem for us, because now, having done a little bit of work, we can now plug in 1 for x and compute the limit. So x plus 1 becomes 1 plus 1, which is 2. And so the answer is 1/2. Once again, the graph strongly suggests that the limit should be a half. Okay, it doesn't actually prove that it's a half, but it strongly suggests that. And our analysis over here using some algebra again confirms that what the story that the graph is telling us. Alright, so once again, thanks for watching, thanks for listening. It's been a really fun week at Sherwood High School. Let's keep it personal and positive. Peace out.